Hello and welcome. Let's solve another interesting question. And this question is coming for what? From GATE. Alright. Two bars AB and BC are connected by a frictionless hinge at point B. Bar AB and bar BC, they are connected by what? Frictionless what? Hinge, which is also known as your what? Pin. This is also known as a what? A pin support here. Alright. So now the assembly is supported and loaded as shown below. Alright, you can see the diagram. So we are asked to draw the shear force and bending moment diagram for the combined beam AC, clearly labeling the important values. Also indicate your sign conventions. Alright, so for us to solve this question, you can see that we have a frictionless hinge, right? Alright, so for us to solve this question, we are going to split this. That is, we are going to break this beam into two parts. That is, into AB and what? And BC. Alright, so I'm going to be doing that, then I'm going to be redrawing the diagram. Alright, so here we are going to have this. Now, this is what we are going to have if we break this beam into two parts. Alright, so I will not be drawing this rolling support here again. I'm just going to be drawing the free body diagram here. Alright, so for us to draw the free body diagram of this rolling support, the free body diagram is nothing but what is the it only allow movement in the what? S direction, but it prevent movement in the Y direction. So we are only going to have what? A reaction at what? At C. So here we are going to have C here. So we are going to have our reaction starting downward, upward rather. Alright, let's just take it to be upward. Alright, so arrow subscript C. So we have two load. We have two load here. We have another load. Alright, so they are equal 100, 100, right? So we have 100 kilonewton, 100 kilonewton. Alright, so here, this point, we have B here. We are also going to have B here. Alright. Alright, so now, you know, for two things to combine together, definitely one must be what? Positive, and the other one must be what? Negative. Alright, so the meaning of that is, if we have a upward force here, we are going to have a downward force here, because we break them into two. Alright, so here if you have an upward force here, if you have an upward force, here we are going to have a downward force. Alright. So here we are going to have, it's going to be reaction at B. So here too is going to be reaction at B. Alright, so here is our A. So here we are going to have a both vertical and horizontal reaction here, and a moment. But here, because we don't have any horizontal force, we are going to neglect that. So we are just going to put our moment. Let's put it to be M subscript A. Alright. So now what other thing do we need? So the distance now. So I just want the work to be neat. 1 meter. Here we have 2 meters. Alright. Alright, so here we have 1.5. We have here to be 1.5. Alright. Now, so this is what we are going to have. Alright. So now I'm going to be doing our calculations here. Alright, so let's start with bar BC. Alright. So bar BC. Alright, so for bar BC, so we know that the sum of upward force will be equal to the sum of what? Downward force. Alright. So now it means that RB plus RC will be equal to what? 100 plus 100, which is what? 200. So this will be what? Equation number 1. All right. So let's take moment about point B. So if we take moment about point B, it means the summation of moments about point B will be equals to what? 0. All right. So if we do that, what are we going to have? So we are going to have, we stand at this point. So we are going to have ROC multiplied by the total distance. So it means that ROC, also C multiplied by what? By 4. All right. Then 100 multiplied by 3 minus 100. Sorry, please. For us to do this, because we are told to clearly indicate our sign convention. All right. So let's clean this part. All right. So let's clean this part. So here, we're going to be taking upward force to be positive and downward force to be what? Negative. All right. So if we are taking our upward force to be negative and our downward force to be our upward force to be positive, downward force to be negative, the meaning of this is this: upward force will always produce what? Anti-clockwise moment. Is that clear? Anti-clockwise moment. While downward force will be producing what? Clockwise moment. So it means if upward force is positive, anti-clockwise moment is also going to be what? Positive. And if downward force is negative, it means clockwise moment will also be what? Negative. All right. So now if you look at this one is going upward. So it means ROC multiplied by what? By 4. And it is giving us a what? Anti-clockwise moment there. So we are going to have ROC multiplied by 4, then minus what? 100 multiplied by total distance, which is what? 3, minus 100 multiplied by what? Multiplied by 2. Everything will be equal to what? 0. So here we are going to have 4 R sub C minus 300 minus 200 to be equal to what? 0. All right. So here we are going to have 4 R sub C minus 500 to be equal to what? 0. All right. So if we move this to the other side, 4 ROC will be equal to what? 500. So if we divide both sides by 4 now, then our R sub C will be equals to what? Will be equals to 125. All right, 125 kilonewton. All right. All right. So now the next thing now is we are going to calculate our ROB. All right. So we know that our ROB plus ROC is equals to 200. So it means that R subscript B will be equals to 200 minus what? Minus 125. So ROB now will be equals to what? Will be equals to 200 minus 125 is nothing but what? It's nothing but 75 kilonewton. All right. So now the next thing we are going to be doing is we are going to be calculating the shear force calculation for bar BC and the bending moment for what? Bar BC. All right. So for bar BC, the shear force calculation now. So here we are going to starting with the shear force at what? At C. All right. So the shear force at C, we know from the definition of shear force is the algebraic sum of forces acting on the beam, either to the left or to the what? To the right. All right. So now if we stand at point B here and you go towards your right hand side, do we have any force? No. The only force that we have is ROC. So the shear force at point C is the same thing as what? The reaction at what? At point C, and which is nothing but what? 125. Don't forget, we are still making use of this sign. This sign is constant throughout. This is the sign we are going to be making reference to. So we said our upward force is positive. So it means here we are going to have 125 kilonewton. All right. So now the next thing we are going to do is we calculate our shear force at this point. So let's name this point to be what? M, and this point to be what? N. So now it's going to be shear force at point M will be equals to what? Will be equals to negative 100. Negative 100. Because we said downward force will be what? Negative. All right. So, negative 100 plus what? Plus ROC. Let me do it clearly. Don't want to jump any step. All right. So we start at point M. We are going to have two forces. We have one force to the right, and we also have one force at what? N. So here it's going to be what? ROC. Our ROC is nothing but what? It's nothing but 125. So it's going to be 125 minus what? Minus 100. So that is going to give us what? 25 kilonewton. Alright. Alright. So now the next one is on N. So the shear force on point what? N will be equals to, so if we start at point N, we are going to be seeing what? 3 forces. So now it's going to be what? 125 minus 100 minus 100, which is what? Minus 200. So this is going to be what? Minus 75 kilonewton. Alright. So now let's do the bending moment calculation on what? On bar BC. So the bending moment calculation on bar BC now. Bending moment calculation. Alright. So now for at point BC, so the bending moment at point C. Alright, you know bar BC now becomes a simple supported beam, right? And we know that the moment on the simple supported beam at the end of a simple supported beam is nothing but what? 0. Alright, if you don't understand that, this is it. The bending moment at point C is this. So now here, if we start on point C, we only have force, an upward force here, but we don't have distance. So it means that, and we know that moment is what? Force times perpendicular distance. So when there's no distance, there's no moment. So this is going to be equals to what? 0. Alright. So now let's go for the bending moment at point M. Bending moment at point M. Alright. So now if you want to do this, this is going to be what? At point M, we are going to have this point, then this is the force and the distance. So 125 multiplied by 1 is still what? 125. Upward force is still what? Positive. So it's going to be what? 125 kilonewton meter. Alright. So now let's do for bending moment at point N. Bending moment at point N. So this will be equals to, this is going to be 125 multiplied by 2. 125 multiplied by 2 minus what? 125 multiplied by 2 minus 100 multiplied by 1. Minus 100, which is 100. And then 125 multiplied by 2 is nothing but what? 10, that is 4, 5, then what? Then 2. So that is 250, right? 250. So 250 minus 100, that is 150. So here we are going to have here to be what? 150 kilonewton meter. Alright, that is it. Alright. So now the next thing is the bend moment at point B. So the bending moment at point B will be equals to what? 0. Alright. But if you because you know I already said the bending moment at the end of a simple supported beam is nothing but what? 0. If you still want to prove this, we can prove this. If you stand at this point and you take your moment, ROC multiplied by 4, that is 125 multiplied by 4 minus 100 multiplied by 3 minus 100 multiplied by 2. So 125 multiplied by 4 is what? 500. 500 minus 100 multiplied by 3 is what? 300. That is 500 minus 300. Then 100 multiplied by 2, that is 200. Minus 300 minus 200, that is 5 minus 500. So 500 minus 500 is still what? 0. So it shows that the bend moment at point D is what? 0. I hope we understand. Alright, so if you want to consider bar AB. Bar AB now. Alright, so I'm just going to do that here. There's nothing much on bar AB. Alright, so we are going to be calculating the reaction. Now, we said ROA, we have ROA here as upward force, and we have ROB here as downward force. So here it means we are going to have ROA minus ROB to to be equals to what? 0. Now, because we said upward force will be what? Positive, and this one to be what? Negative. Downward force will be what? Negative. So it means we sum this together. RA minus RB is going to be equals to what? 0 for equilibrium. Alright. So now it means that our RA now will be equals to what? RB. So it means that RA is equals to what? RB, and is equals to what? RB is what? 75. So it's going to be what? 75 kilonewton. Alright, so let's go for the shear force now. So S dot F. Alright. So now the shear force at point B is nothing but what? Don't forget, this is a downward force. It's going to be what? Negative 75. Negative 75. So the shear force at point B is going to be what? Negative 75 kilonewton. Alright. So, and the shear force at point A now is going to be what? It's going to be 75, negative 75 plus what? Plus 75, because our RA is equals to what? 75. So this is a downward force, which is negative 75, and this is a upward force, which is positive 75. So the shear force at point A will be equals to what? 0. Alright, so let's go for the bending moment now. The bending moment. Alright, so the bending moment at this point B is going to be equals to 0, because here we only have the force, we don't have the what? Distance. So here we are going to have bending moment at point B will be equals to what? 0. Alright. So now if we stand at this point now, the bending moment at point A is going to be what? It's going to be RB multiplied by what? Multiplied by 1.5. But don't forget, our RB is a downward force. It's going to be what? Minus 75 multiplied by what? 1.5. So 75 multiplied by 1.5 is going to give us nothing but 112.5. So 112.5. So we are going to have bending moment at point A. That's 112.5 kilonewton meter. All right. So now that we have everything that we need on the board now, so let's draw now. So now I'll be tracing everywhere we have load. I'll trace the point downward. Then I'm going to take my reference line for shear force and my reference line for what? For bending moment. All right. All right. So now we are going to be drawing the reference line for our shear force and the reference line for our bending moment. So here is going to be 0, here is going to be 0, here is 0, here is also what? 0. So this is the reference line for our shear force, and this is the reference line for our bending moment. So any point above this line is positive, below is what? Negative. Above this line is positive, below is what? Negative. All right. So let's go for our bar what? BC. All right. So the shear force at point C is 125. So this is 0. So we can move to 125. So let's just assume that this whole length here is our 125. All right. Between C and M, we don't have any force. So this line is going to be constant. We have a constant line here. All right. So now, and the shear force at point M, the shear force at point M is 25. So if this whole length is 125, so let's make 25 to be at this point. So it means our 25 is going to be somewhere around here. All right. So and between M and N, we don't have any force. So it's also going to be a what? A constant. All right. So now at point N, we have what? Minus 75 kilonewton. So from here we are going to be going to the negative side. So now let's just make this place to be our what? Negative 75. So let's say this is it. All right. So between N and B, we don't have any force. So it's also going to be a what? It's also going to be a constant line here. All right, so at point B now, point B, the shear force at point B. All right, I did not calculate the shear force at point B here. Oh, so sorry. All right, the shear force at point B is going to be what? If we look at point B, we have all the four forces, right? So it's going to be 125 minus 100 minus 100, then plus what? ROB, which is what? 75. 125 plus 25 is 200. 100 plus 100 is what? 200. So it's going to be what? 200 minus 200, which is nothing but what? 0. All right, so it means we are going to go back to 0. So it means the shear force at point B is nothing but what? 0. Please take note of that. The shear force at point B is 0. All right. So it's going back to what? 0. So it means this part is positive, while this part is what? Negative. All right. So here is our 125. So here too is going to be 125 because it's constant. So let's indicate 125 kilonewton. All right. So here is going to be our 25 kilonewton. All right. And here is going to be our negative 75 kilonewton. All right. All right. So we can decide to shade. All right. So that's it. Now, the next thing we are going to do now is to draw the bending moment diagram now. All right. So, we have not drawn the shear force for bar AB. All right. So, for bar AB now, the shear force at point B is what? Negative 75. So, we are going to be moving from this point to what? Negative 75. And don't forget, this is 75 here. So, it means we are going to just have the same distance here. All right. So here is our 75. All right. So now between B to C, we don't have any force. So it's going to be a constant line as well. All right. So now, and the shear force at point A. The shear force at point A is 0. So we are going to go back to what? To 0. All right. So this is negative. So you can shade it as well. All right. So we are done with shear force at this bar BC and bar AB. All right. So now let's go for this bending moment now. Now, to go for the bending moment, the bending moment at point C is what? 0. So this is 0 here. All right. So the bending moment at point M is what? 125. All right. Now, this is our M, right? And this is our 0. All right. So for every straight line that we have here, we are going to be replacing with what? Vertical line on our what? On our bending moment diagram. All right. So now here we have 0 to 125. So now let's pick this point to be our 125. So let's join this point to this point. All right. So this point is 125. 125 kilonewton meter. All right. So now, and the shear force at point N. At point N is 150. So 150. You know, this if from year to year is 125. So 150 will be somewhere around here. So let's just put it somewhere here. All right. Let's just take it like this. It will be what? 150. 150 kilonewton meter. All right. So now that is point N. All right. So at point B now is what? 0. So it means that This place come back to what? 0. All right. So it's come back to what? 0. So now here is our positive side. So all right, so that is it. Now the next thing is for our what? Our bar AB. All right, so for bar AB, the bending moment at point D is what? 0. So here is 0. Here is 0. And then the bending moment at point A, the bending moment at point A is 1125. All right, 1125. All right, the bending moment here is 112.5. All right, but please, maybe I will omit something here. We said our upward force should be positive and our downward force will be what? Negative. So if we are taking moment about this point, this is a downward force, it's going to be negative RB multiplied by what? 1.25. So here is going to be negative minus, so the bending moment at point what? A is going to be equals to minus 112.5. all right, so here if we go down, this is 0 here, so let's just take any point here to be our what? 112.5. So here is our 112.5 minus 112.5 kilonewton meter. All right, so that's it. So this is negative. All right, so you can decide to shade now. All right, so this is everything that we have, and I hope this is well understood. So this is the solution to this question. So I believe we've learned one or two things. Please don't forget to share this content with your friends who might be in need of this, and don't forget to also stay tuned on this channel as we are going to be dishing you out more interesting and difficult, but we are going to make sure we simplify